So Paul is from Lima, Ohio. Does anyone know where that is? Wow. Apparently, Lima is a popular place. I have no idea where Lima is. Someone's going to have to tell me. But yeah, Paul's from Lima, and the cool part is he works at Unicity, which is a company out of Mountain View, California. That's the wonder of the internet today. You can work as an operations engineer for a company based out of California in Lima, Ohio. Paul tells me most of the operations team at Unicity is remote. So we're talking about containers. Docker. Talking about containers, it's a big thing right now, right? It keeps on sticking around, not going anywhere. Some of the challenges with containers is visibility into the environment, how something fails. And that's really what Paul's going to be talking to us about. Oh, look, it's Stephanie. Stephanie the unicorn's back. Stephanie's a pretty popular unicorn, lady unicorn. So she's going to be hanging out with us for a couple hours. So if you missed an opportunity to say hi to Stephanie, take a photo with Stephanie, maybe fisticuffs. Are you being nice to Stephanie over there, Paul? Oh, please don't hit her. Only hugs. Unicorn hugs. Hug ops over there. All right, that's great. Please join me in welcoming Paul. Hands together.
Howdy. Yeah, so as he said, I work at Udacity. It's really funny, you tell people what the name is, and I think my loan application lady said is, how do you spell UDA City? And so, yeah, so we get all sorts of comments from that. So I work for Udacity. It's a small startup in Mountain View, California. We have a very, very small ops team, and like Warren said, we're almost all remote. We've got Denver, New York City, and Lima, Ohio. When I started working at Udacity, it was living in Arizona. And so there's, let me just tell you a little bit about where we're coming from for this talk. At Udacity, I'm on the platform team, and we, because we're slightly insane, run our own microservices platform internally for the teams. Right now, I think we've got about 130 production microservices. And so yeah, it's a little nuts. And when we first started this platform, Udacity was entirely on Google App Engine, which is a big monolith. And we made the decision to move off of Google App Engine onto AWS because international reasons. Apparently, Google and China aren't BFFs. And so we decided we said, while we're at it, why don't we just break apart the monolith and we'll do our own microservice architecture. And when we started, a year and a half ago, a lot of the off-the-shelf components and software as a service solutions didn't do what we needed. And so we've come up with this. And internally, we're deploying all the time. Like I said, we've got about 130 production microservices. And that's kind of the zoo. I'm not going to go into all the details of this, but I'm going to give you just a quick this is a really, really high-level overview of our network architecture. And we're into AWS in 3 different availability zones. And the only thing that's interesting for this talk is that bottom layer, the Weave overlay network. We have an HA proxy routing layer that forwards traffic down to those Docker containers down there. And we'll talk a little bit why that's useful for this talk in a moment. Yeah, we're going to talk about visibility. So So everyone says containers, VMs, cattle, not pets. So the idea is your container, your VM gets sick, you shoot it in the head. The trouble with that is, as we move to these new architectures, serverless is another key one where we've actually looked into it a little bit, and some of the operational visibility tools aren't there for us yet. So it's very, very interesting. There was a talk about it yesterday, and we'll probably be looking to move to some of that type of architecture in the future. But until we can solve the visibility problems, we won't be doing that anytime soon. And I'm going to give you a little anecdote as to why. So when you break apart the monolith, a lot of your traditional visibility tools, they don't work anymore. Good luck hooking up a profiler to your microservice and getting any kind of information that's useful for your distributed system. Because all the things that you care about, like why is this function call slow, it's no longer a function call, it's over the network. And so, but it's even worse than that, right? So once you move to Docker, a lot of the traditional things that you use for introspecting a running system, unfortunately, don't work as well as you'd hope. And we'll talk about that. So let me start with a story. So last May, our team, because we work remote, we go back to Udacity a couple times a year, hopefully every quarter. And we did a kind of a field day for the team. And we went to the Computer History Museum. And they have a working IBM 1401. And this was absolutely fascinating. And you go in there, and it's this big, giant room. And it used to be, when you're a startup, just table stakes was you had to roll out a data center. Well, now we just swipe our credit card and pay Amazon ungodly amounts of money. And but it was really neat to walk in this. It's like a time capsule. You walk in, and you can see and touch your computer. If you're angry at it, you don't just have to reboot it. You can actually hit it with a bat if you're mad, because it's all there. And you can touch it, and you can smell the machine oil, and it was really cool. And more than that, that is core system memory. It's 400K, 4K, 4K, off by order of magnitude. It's 4K, and look at that. You can even zoom in. You can almost hook up a multimeter and see the zeros and ones. That's visibility. I mean, why is my machine not working? And more than that, they could go in, and they had this big, giant printer, and they could print out the contents of core memory, a core dump. And this made me really, really sad, because right around that time, I was seeing this in my logs. And back to that architecture diagram, those HA proxy routing layer, those are all in Docker containers. And that's a problem because, well, this is the symptoms we were seeing. We're like, okay, we've got Datadog. We've got our whole system instrumented, and we can go and we can see that our healthy host count is going up and down. It's going nuts. And we did a whole bunch of analysis and a bunch of dead ends and red herrings. And ultimately, we needed a core dump. And yeah. So we can have all the metrics we want, but we didn't have any kind of visibility of what was going on in the process as it was running. And Google Docker core dumps if you want a really sad time. And because out of the box, default, Docker doesn't provide this to you. And so these are some of the things that we learn when we're operating Docker at scale. And one of the things that everyone likes to liken Docker containers to is it's a VM, right? But you're actually sharing the same kernel. And so what happens is if you are running a Docker container on your host system, and like us, maybe you're using Ubuntu, and Ubuntu doesn't just have they set up proxys kernel core pattern to, they don't even dump it to a file, they dump it through a Python script that's on the host, and good luck because that's not in your containers. And because you're sharing the kernel, you don't get core dumps. And so these are one of the things we learned the hard way. And so we get a core dump, okay, that's great. So we got to configure our host. What you have to do basically is, if you're controlling your infrastructure, you say, okay, you know what? I know that all my containers are going to have /temp, or all my containers are going to have a current working directory. That's usually the case. So you got to set that up, and then you also got to do this. Docker out of the box does not give you core dumps, and so we set this, and now we have running water again. I mean, it's amazing. Now we can hook up GDB, and oh, by the way. Quick sales pitch for GDB. There are so many things in this space that you can learn. GDB is an old tool, it's not sexy, but oh my word, in terms of bang for your buck, in terms of the time that you spend to learn it and what you get back for it, GDB is amazing. You can even have source inline and step through and see stack traces and inspect it's a debugger, right? But hugely undervalued. So this is the money payoff. Basically what was happening is we had a service in our infrastructure that was getting called by segment. And periodically, it was returning a response that HAProxy didn't like. And there was a bug in zlib, or at least the way HAProxy used zlib, it's now fixed. And we were getting core dumps whenever they tried to compress the response. And we could see that because we had visibility. And so now this was a little bit ad hoc, and we are at Udacity trying to build some tools to automate this so we can get core dumps live out of running Docker containers. That's some work ongoing. But this is the result. All of a sudden, everything was happy again, and it's great. So anyway, the point is, when we're talking about process level visibility, everyone always ticks the main boxes, metrics and logging. And we have that, and we'll talk about that just in a little second. But there are certain things, process level visibility, being able to get that core and be able to see what's going on at a system level is really critical. And a lot of times these things get missed. And so for some of you guys, a little background, I'm a developer, and I'm living proof that there's hope for developers, that we can actually eventually care about operations. And so I very much come from the developer side of the house on the DevOps split. And so some of these things are things that we learned hard. And some of you out there be like, yeah, of course. I need to be able to get core dumps on my system. But for some of us, running a Docker, these are hard learning curves. So yeah, so as far as in terms of monitoring, this is pretty standard stuff. I mean, we have a single pane dashboard for our microservices, and we have routing and system level top-line metrics and RDS instances under the covers, and we associate these things. We happen to be using Datadog, but if you use Datadog or Prometheus or whatever, these are table stakes to get visibility in your system. So we won't spend a lot of time on this because I know these are near and dear to our hearts, these types of things. But the basic idea is you run a Datadog agent or some kind of monitoring agent on each system, and every single service you deploy, you need to tag it with a certain amount of metadata so you can get these kinds of graphs and stuff. Same thing with logging. We have our own bespoke logging system as well. The key takeaway with metrics and logging, and I won't belabor this point because these are, like I said, they're table stakes. But you need to be able to, when you deploy your services, you need to be able to aggregate on metadata tags. And we have all of our services, when you deploy, they get a Udacity name, an environment, and a version. We can filter both metrics and logs in these. The key thing I want to point out about this, though, in terms of the context of visibility, is that metrics and logging are great. But we can do more, and we're going to talk more about this in just a sec. But the key takeaway here is, and this is a little bit opinionated, but I feel like logging at some level, when we're resorting to logging, we failed somewhere in our visibility pipeline because, so think about it, if you are trying to debug a system and all you have is logs, like all I had was this, and there's nothing more, and I have that, but I don't have like deeper system level visibility, that's a problem because, well, there's an obvious reason why it's a problem, but you, just logs alone, you're debugging a system that's already misbehaving, and you're depending on the developer, that crazy developer that wrote this system that's misbehaving, that he actually wrote the logs right. And that's not always the case, and especially so we have a service right here. This is Hoth. This is our authorization service, and we were logging dutifully at our routing layer unique IDs for every request that comes in, but we weren't correlating those with actions that was going on Hoth. And so when we had some scammer that was creating spam accounts for us, we couldn't even do IP blocking because we weren't correctly logging. And this gets us into distributed tracing, which we'll talk about in just a sec, but. Key thing is, these are hard learned lessons. We rolled our own logging system. It's elk basically. But one of the things that our developers ran into was stream level aggregation, and this is I'll briefly mention this. When you are using a lot of the out-of-box solutions out there, they're going to do one log event per line, and there's a whole bunch of ways to skin this cat. We ended up writing our own log aggregation daemon that runs on each single host and does the stream level aggregation, so you get nice, pretty stack traces and Kibana and that sort of thing. But these are all concerns that a wiser person and someone with maybe a little bit more background experience wouldn't have maybe made these mistakes up front. But these are mistakes we made, and we fixed them now. But so it's really very much a journey of discovery for us. So those are the standard table stakes type stuff. We've got logging and metrics, and these are and basically the way this works in terms of operating it, you're going to have some kind of aggregation daemon and a metrics collection daemon on each host. And that's all pretty standard stuff. But we're trying to do better. So let me show you just a sneak peek. I'm really excited about this. How many of you here know about flame graphs? Anybody follow Brendan Gregg, Netflix guy? Yeah, so just go Google this. Flame graphs are pretty awesome. You can, it's basically a visualization to help you pare down the noise that you get when you get these massive stack traces. So if you do strace, it's going to dump a whole bunch of stuff. Flame graphs are a really nice way. The way you read them is the width of the bar is how much time was spent, and the stack is basically that. It's the stack. And so Trouble is, getting flame graphs out of Docker containers is a lot of fun. And by fun, I mean not so much. And so what we've done is we've written, this is open source now, and I can post a link for it later. But it's basically, we will run this. This is not in production yet. This is something where we just hot off the presses this week. But basically, we can run this on each host and hop in and select a Docker container and get a nice flame graph just on demand. And this may or may not work if I. This is basically if it doesn't work, we can skip to the next one. But it's kind of neat. So you hop in, you set a sampling rate and a duration, and these all underneath the covers. This is using facilities that are in the Linux kernel, perf events, and but we're marrying this with this new microservice architecture that we've rolled out. And so we can do this to our heart's content. The nice thing about Brendan and Greg's project for flame graphs, they're SVGs and they're interactive, so you can zoom in and you can do this live. And the performance impact is there's definitely a performance impact on your own system. You're effectively running a kernel level profiler, but it's not. So far in some of the tests I'm seeing is maybe 5% overhead at times. It depends on what you're profiling. So let me move on to the next slide. If I can. So that would be, this is why. All right. Yeah, so just a quick recap. What we've been talking about so far is just getting visibility back into a Docker-focused microservices architecture and some of the table stakes you need to get that visibility back. Basically, you're going to need to automate some of the ad hoc queries that you hop into a host and you run perf events or you run GDB and some of these things. You're going to need to have some daemons that run on your hosts that allow you to break into these Docker containers and get that visibility out. So, but that's not enough, right? So, like I said before, when you break apart your monolith and you have a microservice that's a couple hundred lines long and it's calling to a whole bunch of other microservices, hooking up this type of process level visibility gets you very little. I want to know all the microservices that my user interacted with on his session on October 5th, and these are things we can answer. But setting up these tools, it's we're going to do a quick deep dive on, or not deep dive, a quick overview of some of the tools we have. Talk about now a lot of you know about this, the Daper paper from Google. I looked at the date, it's actually a little old. This thing came out in 2010, and they had been running it in production for 2 years. And just now, we're starting to see software as a service companies like APM companies and Datadog and New Relic offer services based on this model. And it's not a complex idea. But the basic idea is you're going to run yet another agent on your hosts. And the key thing here is that your individual applications are going to have to be instrumented. In a lot of cases, it doesn't take a lot of work from the developers to opt into this. But basically, it's distributed tracing. And because of the volume we're talking about, every time you have an RPC call, you're going to emit a trace or a span. And because of performance reasons, and you can't afford to do that aggregation right in line where you're doing your RPC, you're basically going to have a global unique ID for each span. They're going to go up to collector. It's going to get aggregated, and you're going to dump, and I'll show you a little bit of a screenshot of what that looks like. That's kind of what it looks like. This screenshot actually I grabbed was a demo I was running using Linkerd, and this is kind of a neat way of running this. Linkerd is basically an RPC proxy, and it'll automatically generate these types of spans for you. But what you can see is you can drill down, and you can see how much time was spent, and each line on the left is an individual microservice, effectively. And Datadog also has a product in beta, which we're trialing. I wish I could give you lots more operational pearls of wisdom about how this is running. We are just starting to use this, and so we're building the train as it's moving. Kind of crazy, but you get to do that when you're in California. So this is basically a distributed trace, and every single line in there is talking to a different distributed service. This is an upside down flame graph, and you can drill down and see exactly how much is spent on each service and how often they're called. The key thing with Daper is that when you scale this, you end up having a sample. And usually that's not a problem, because if you have a performance issue that happens once every 100 calls or so, that will show up in the sampling, especially if enough volume. If you don't have the volume to require the sampling, you just record every trace. It's not. So that's distributed tracing. Let me recap real quick. Looks like I've got time, so we can go into it a little bit. But I wanted to. The basic overview is we have to be more conscious as an industry of maintaining the visibility that we had. When in the bad old days, right, you had your own data center, and you can go in and you actually physically see the server, and if the server is misbehaving, you could pull the plug. I mean, you can't do that now, right? And now you have a Docker container, and you can, Docker stop or whatever, and rage quit the Docker container. But the sad thing about every time you do that, and every time I do that, you die a little inside. At least I do. And if you don't, you should. Because what happens is you're basically thrown away a bunch of state that would allow you to really understand what was going on. And when we don't understand our systems, we're not effectively operating them. And we all know this, and even we knew this going in, but we had schedule crunches, and some of these tools that visibility tools, we're now doubling back and adding to our system, we didn't have when we launched last December. Insane. We're living. And in Udacity, by the way, I love the fact we have a unicorn, because we just hit unicorn status about 4 or 5 months ago. And so $1 billion, yeah, we're still hemorrhaging cash, but yeah, I hope this isn't recorded. So anyway, but yeah, by the way, quick sales pitch. Udacity is pretty awesome, and we are hiring, and I have to just kind of throw that in there. So anyway, let me just mention a couple things. I'll have a bunch of resource links I'll send out, and I'll tweet out about, and with the hashtag DevopsDays. But these last 3 points, and these are things that this is a whole nother talk, but effectively, as these systems scale, we're all going to become big data engineers, and we're all going to become data scientists. Because once you have this volume of tracing, I mean, think about it. You're making a network call every single time, and we're talking about amplification, right? So if you're tracing all your RPC calls, and you're also adding application level tracing for what your application thinks of as a transaction, this is a big boost in your network monitoring too. Your network monitoring is going to go up, and suddenly there's so many pieces that the only way to get any kind of intuition for what's going on in your system, we're going to have to apply some statistical methods, just like you tag a whale in the ocean. You can't track every single blue whale, so you tag a few of them, and you have statistical models to track those. And the people in the network grid, electrical grid company, they've been doing this stuff for years. We have a lot to learn from them. If you've been following Netflix Tech Blog, they're doing some really cool stuff with network flow visualizations and all these new tools that are coming out, tracing application performance monitoring. I mentioned Zipkin and Datadog, but there's a whole slew of software as a service vendors out there that if you aren't crazy enough to stand up your own Zipkin, you can solve it with money if you have money. So these are all tools that we are just now starting to dip our toes into at Udacity, and maybe next year we'll have a much better experience for it to talk about those. But in terms of process level visibility, we feel like we're starting to hit our stride with that operationally. So that's basically it for me. The one thing I wanted to say, I want to thank my wife, Alicia, so much for helping me with this talk. She helped focus me and bounced ideas off me, and I'm really lucky to be married to a wife that's that intelligent and smart and can help you with this kind of stuff. So I'm up here, but you don't see her, but I just want to shout out to her because she's awesome. And that's it. So.
So we have 6 minutes for questions.
Oh, love it.
Would you like to take questions?
Sure.
Are you sure?
I mean, goodness, we roll our own platform as a service. How hard can that be?
Any GDB flags you want to ask them about or anything? No one? I guess you're off the hook.
Yeah, just the other thing. I mean, this is obvious to you if you use GDB in the past. But when you are getting that kind of visibility into a running process, you're gonna do some pretty cool stuff with GDB. You can attach GDB to running processes. and if you use UGB, this is like a no-brainer, but this will trip people up that are using it the first time. Debug symbols. So when we were debugging that HTTP proxy routing layer, we had to roll our own HTTP proxy container and build it from scratch with debug symbols because, I mean, reasonably enough, those things aren't built into the standard packages that are distributed on OSs. So you have to be intentional about this kind of stuff. Even the things like flame graphs, those are things that you're going to need debug symbols in your host when you're doing those perf events. Otherwise, the stack traces are just worthless. So.
Do you use any other system profiler tools like dtrace or anything, or strace or anything like that?
Gosh, I wish. dtrace. So has anybody been following the kernel developments with BPF and BCC? Yeah. Good. So dtrace, OpenSolaris and Illumos and SmartOS, they've had running water in plumbing for years. And Linux is just now starting to get the quality of tool that give you dtrace. There's been a number of efforts to port dtrace to Linux that are, the ones that are open source aren't super mature, and the other one you have to pay Oracle a crazy ton of money for. So I mean, if you have money, solve it with money. So there's a new thing in the kernel of 4.9, and probably won't hit mainstream distros for another year or two, but we can get dtrace quality tracing without the performance hit you normally get with normal tools. Like now, obviously, the folks at Csysdig and Sysdig, they're an awesome company and they're doing some really cool stuff. When we launched, we ended up going with Datadog because they've been around a little bit longer, and we had a little. They had out-of-the-box integrations for Mesos and Marathon, which we're heavily dependent on. But Sysdig also provides this type of stuff, network visibility and drill down all the way down to your microservice. It's pretty awesome. So anyway, sorry. I'll try to stop rambling.
Thanks,
They're
Paul.
going to bring out the hook.
Big round of applause for Paul.